I want to make a few general comments about the concept of using virtual points in systems where you have differential boundary conditions. So just to start off the conversation, I've listed two examples of systems that would have a differential boundary condition. So imagine I have a heat fin, I have heat transfer occurring in this direction. In fact, I'll draw a few lines. So you have a heat transfer that may be through conduction. I realize we haven't studied how to set up a problem like this or a differential equation, but if you're given one, you can still solve it. And we may have transfer to the air surrounding the heat fin, but a very common assumption is to assume that the tip is very small. And so the direct heat transfer that occurs off the edge of the tip can be neglected, and then the sort of corresponding boundary condition would be that there's no temperature gradient at the edge of the tip. So dt dx equals 0. This is another example over here. If you look at a PFR, this is a problem from the book. It considers axial dispersion in a PFR. Again, that's not something we're going to discuss in any detail in this class. But again, you can be given a differential equation and expected to know how to solve it. In this case, the input concentration ends up being balanced with the concentration at x equals 0. By the way, these are not always the same. Quite often you have a discontinuity between the inlet, or the composition of the inlet stream and the composition inside the reactor at x equals 0. And then you have this other differential term. So it's not a requirement, but commonly we use virtual points to treat this system. So let me start with the heat fin. So we discretize our domain, right? We end up with x sub n, where usually n times h is x sub n, and that's equal to the length of our rod. And we often just consider an additional point, x sub n plus 1. So what this actually is L plus h, and we're actually looking at a point that is outside the domain. So this point does not have a physical meaning, but it actually can have a mathematical meaning. So for example, we can approximate dt dx in terms of a centered finite difference formula. And that would be, if you evaluated x equals L, that would be t of n plus 1 minus tn over 2h. If you look over here at the PFR, over here, say we're using a centered finite difference formula, then we would evaluate this term to be C1 minus C minus 1 over 2h. And again, we would be looking at positions x0 through x sub n, but this x sub minus 1 would actually be a virtual point that is actually outside the PFR, correspondingly C minus 1, C0, C1 through Cn. This C1 is actually not a physically meaningful concentration. So, but my point here is that virtual points, meaning these sort of physically unreasonable points, or these points that are outside the domain, they actually can have mathematical significance. So by introducing these points, you often make it possible to formulate either the boundary conditions or evaluate the main differential equation at positions that you wouldn't have been able to before. So for example, say you wanted to evaluate the differential equation for concentration versus x. I haven't actually drawn it, but say you wanted to evaluate it at x equals 0. If you're using centered finite difference formulas, it would involve c minus 1. And so you wouldn't be able to evaluate at x equals 0 without considering that virtual point. Now, one important point is that we don't always really need virtual points. They're often kind of optional. So I didn't have to use a centered formula here. I could have used a forward formula that avoided looking at c negative 1. Likewise, over here, I could have used a backwards formula that prevented me from needing t of n plus 1. So virtual points are not really a requirement. If you're determined to avoid them, you can avoid them, but my point is that you don't need to avoid them. Quite often, it's okay to introduce them as a mathematical convenience and then solve for them, and then effectively throw them away. So example 3 in our finite differences YouTube videos, example 3 was the one where we actually looked at a no flux boundary condition for heat transfer between two walls by a rod. And that actually uses virtual points. So it is something that I would recommend that you play with because they actually can simplify the math and be very convenient.